Matter is all around us, but did you know it can be classified into 3 states with unique properties? These states are solid, liquid, and gas. Solids have a fixed shape and volume like ice or rock. Liquids, such as water, take the shape of their container but have a definite volume. Gases, like steam, fill the entire space available to them. But that's not all. Matter can change from one state to another through processes like melting, freezing, and evaporation. For example, when ice melts, it turns into liquid water, and when water boils, it becomes steam. These changes are all around us, from the water cycle in nature to the way we cook food in our kitchens. Understanding these states and changes helps us grasp the fundamental principles of science and the world we live in. Let's explore the fascinating world of matter and see how these states interact in our everyday lives. Matter can be classified into 4 fundamental states: solids, liquids, gases, and plasma. Each state has unique characteristics and behaviors that distinguish it from the others. In solids, particles are tightly packed in a fixed, orderly arrangement. This gives solids a definite shape and volume. Examples include ice, diamonds, and metals, which are all characterized by their rigidity and structural integrity. In liquids, particles are close together but not in a fixed position, allowing them to slide past each other. This gives liquids a definite volume but no fixed shape. Examples are water, oil, and mercury, which can flow and take the shape of their container. In gases, particles are far apart and move freely, filling any container they are in. This gives gases neither a definite shape nor a definite volume. Examples include air, steam, and helium, which can expand and compress easily. For example, ice is a solid, water is a liquid, and steam is a gas. These transitions between states are common in everyday life. Plasma, the 4th state, is found in lightning, stars, and neon signs. It consists of highly energized particles and is often seen in both natural and man-made phenomena. Matter has physical properties like density, which measures mass per unit volume, and boiling point, the temperature at which a substance changes from liquid to gas. It also has chemical properties such as the ability to burn, known as flammability, or to rust, which is a reaction with oxygen. Other examples include reactivity with acids and bases and the ability to undergo chemical changes. Matter can undergo physical changes like melting ice, freezing water, dissolving sugar, or cutting paper. These changes are often easily observable and can be reversed in many cases. For instance, when ice melts, it turns into water, and when water freezes, it turns back into ice. Similarly, sugar can dissolve in water to form a solution, and paper can be cut into smaller pieces without changing its inherent properties. These are all examples of physical changes where the substance itself remains the same. Even though its form may change, these changes do not alter the chemical composition of the substance. For example, boiling water, evaporating water, and condensing steam are all physical changes. When water boils, it turns into steam. And when steam condenses, it turns back into liquid water. These processes are reversible and do not create new substances. The molecules of water remain H2O throughout these changes, demonstrating that physical changes are about the state or appearance of a substance rather than its chemical identity. Matter can also undergo chemical changes, like burning paper, rusting a nail, baking bread, or digesting food. These changes result in new substances being formed. For example, when paper burns, it turns into ash and smoke, which are chemically different from the original paper. Similarly, rusting involves iron reacting with oxygen to form iron oxide, a new substance. Baking bread involves chemical reactions that cause the dough to rise and transform into a new product. Digestion breaks down food into nutrients that the body can use, fundamentally changing the original food substances. Physical changes are often reversible, such as recycling plastic, while chemical changes are not, like composting organic waste. Understanding these changes is crucial in fields like environmental science and materials engineering. Recycling plastic involves melting and remolding it into new shapes, but the plastic itself remains the same chemically. Composting, on the other hand, breaks down organic waste into simpler substance, which cannot be reverted to their original form. Recognizing the differences between these types of changes helps us manage resources and develop new materials effectively.